In question number 6, we're going to use a bootstrapping technique to come up with a treasury spot rate curve. And what we'll find is our treasury spot rate curve will actually be a little bit above our estimated yield curve. So we're going to make a couple new columns for this. Our first one is going to be our estimated yield curve. Then we'll have coupon payment, CP. We'll have spot rate, we'll have discount factor, we'll have sum, and then we'll have a theoretical strip price. So for our estimated yield, we're actually going to use our actual rates that we got from the Treasury for the first two periods. So that'll equal 0.08% for the half year, and then 0.31% for the year one maturity. But from that point, we're going to actually use our rates found through our Nelson-Siegel method. So we can just reference that, and we'll drag this all the way down. So that's our estimated yield curve. Now off of this, we're going to find our coupon payment, and our coupon payment is going to be equal to our estimated yield curve times 100 divided by 2. The reason why we divided by 2 is our yield rates are given in yearly or annual terms, and these coupon payments are going to be paid semi-annual, so we'll divide it by 2 to get that proper calculation. Let's see. Make sure that looks right. So we'll drag it down, make sure it's filling out. It seems like these are going too high. And then our the next column we're going to want to fill out is our discount factor. For our first two periods, we're going to use a separate equation from what we'll be using the rest of the time. So it's actually going to be equal to 1 divided by 1 plus our estimated yield divided by 2 raised to our period. So we'll drag that down 1 as well. Looks good. And then our sum is going to be equal to that. And then starting in our second row, it's going to be equal to the last sum plus the new discount factor. So spot rate. Now we're ready to start working on getting our spot rate curve. The first two spot rates, similar to what we did for our estimated yield, are just going to equal the actual rates that we got from the Treasury Direct website. But starting in period 3, we're going to use a new equation. So our spot rate is going to be equal to 1 divided by our discount factor, and we don't have our discount factor filled in for period 3 yet, but we'll do that in just a moment and then get this equation working. So 1 divided by our discount factor raised to 1 divided by the period we are in, which is 3 in this case, minus 1 times 2. And we have a problem with our parentheses, so we'll fix that really quickly. Add 1 there. And our new equation for discount factor starting in year 3 is going to be equal to 100 minus our coupon payment times the sum from the prior period divided by our coupon payment plus 100. And then we'll drag our sum equation down 1. Now we can populate the rest of our curve. We'll delete those last 2 ones. So now we can find our spot rate curve, or we'll graph our spot rate curve in our estimated yield curve against our maturity. I'll click Alt-N-D to get to our scatter. And we're going to do scatter with smooth lines. And we'll see that our spot rate is just a little bit above our estimated yield curve. So spot rate versus yield curve. Add our axis tiles. So on our y-axis we have our rate, and on our x-axis we'll have maturity. So question number 7 asks, now that we have our spot rates, to calculate our theoretical price for each strip. So this is actually very easy. All we're going to do is we're going to imagine this is a $100 par. So all we need to do is multiply 100 times our discount factor for each period. And these will be the theoretical strip price for each period. For question number 9, we're going to go onto the Treasury Direct website to see what a 10-year and 30-year bond have recently sold for, and we're going to compare that market price to the price that we would find using our theoretical strip prices to see if there's an arbitrage opportunity in this. So this is going to be question number 9. Or question number 8, I mean, sorry. And we're going to make a row. Well, first things first, we're going to go to the Treasury Direct website. So you're going to want to go onto your web browser and look up Treasury Direct latest auction, and then it should be the very first one. And then you're going to want to go to the notes one over here, and we see that we have a 10-year bond sold on October 15th for 2015, and it has an interest rate of 2%. So we're going to go and transfer this information. Okay. So we're going to have our auction date is 10-15. Our maturity is 10 years. And our coupon rate is 2%. And our market value, find out in just a second. So our market value is $99.41. Okay. So now we're going to want to compare that. So we're going to create a table. We'll have N, our year, because our N and our year are actually going to be different, our cash flow, and our discount factor, and our market value, or sorry, present value is what I mean. So we'll start out 0.5, this will be 1 to 2, and this is a 10-year bond with semi-annual payments, which is why we had the 0.5. So this is going to go all the way to 20. Our cash flow is going to be equal to our coupon rate, lock that, times 100 divided by 2. And then in the last period, we're going to get our principal payment back of $100. So our last cash flow will actually be 101. And for our discount factors, we're just going to copy and paste our discount factors from before. That we got in question number 6, and then these are going to be too far. And we're going to want to paste just the values. So then we'll delete these, and our present value is going to be equal to our discount factor times our cash flow. All the way down. And then we'll find the theoretical price. It's going to be equal to the sum of all of these present values. So we see that the theoretical value is actually a little bit more than the market value. So there may actually be an arbitrage. So now we're just going to do the same process for a 30-year bond. So this will be our 30-year bond. So we're going to want to go to bonds now, and we'll have auction date, maturity, coupon rate, and market price. So our auction date was, it looks like October 15th. Our maturity is going to be 30. Our coupon rate, it looks like it's 2.875%. Let's get our market value. So our 30-year is going to be $99.89. So we're just going to do that same process, and I'm going to actually move this over a little bit. So we'll have N, we'll have year, we'll have cash flow, our discount factor, and our present value. So our N is going to be 1.51. Drag that all the way down to N will be 60, and our cash flow is going to be equal to our coupon rate divided by 2, because these are semi-annual payments, times 100. Control down will fill that up. Let's see, forgot to lock the cell. So we need to lock that. Try that one more time. And then again, in the last period, we're going to get our principal payment back. So add 100 to there. Like we did with the other bond, we're going to need to add, just put our discount factor that we got from question number, what was it? Question number 6. And our present value is going to be our discount factor times our cash flow. We see that our theoretical price is the sum of the present value. And we see that our theoretical price is $100.53 compared to the market price of $99.90. So again, it looks like there's some arbitrage in the valuation.